You will take around 20,000 breaths today. You have probably never wondered what lives in them, because when your body loses fat, that fat does not turn into energy. It does not burn off as heat. It does not leave in sweat. It leaves through your mouth, one breath at a time. A physicist named Ruben Meerman lost about 15 kilograms and asked his doctor where it had gone. His doctor didn't really know, so he asked 150 of them doctors, dietitians, personal trainers. More than half answered that fat is converted into energy or into heat. That answer isn't just wrong, it breaks a rule that has held for 200 years. In a chemical reaction, matter is not turned into energy, it is not destroyed. Every atom that was inside you has to still exist somewhere afterwards, and it has to have gone somewhere you could point at. So, where? Start with what body fat actually is, because it isn't a substance called fat, it's a specific molecule, and you can count it. A typical one is written C55H104O6, 55 carbon atoms, 104 hydrogens, 6 oxygens, 165 atoms arranged as three long tails on a small spine. Look at the proportions. Almost the whole molecule is carbon and hydrogen. Only 6 atoms out of 165 are anything else. That matters more than it sounds. Carbon and hydrogen are the two things a body is best at getting rid of, because they are exactly what it produces all day anyway. Now, the word burning. It's a metaphor that turns out to be almost literal. Your cells oxidize fat, they add oxygen, and they take the chain apart. It is the same reaction as a fire, run slowly in water at body temperature, without a flame, and it makes exactly what a fire makes: carbon dioxide and water. But the fat doesn't oxidize where it sits, so follow one molecule out. It starts inside a fat cell packed into a single oily droplet that fills almost the whole cell and pushes everything else against the wall. A fat cell is mostly storage and very little machinery. That droplet is where the molecule has been sitting, possibly for months. When your body needs the energy, an enzyme cuts the molecule apart at the spine. The three long tails come free and slide out of the cell into your blood. They travel. A fatty acid released from your waste can end up in a muscle in your leg, or your heart, or the wall of your gut. Wherever a cell has work to do, that cell pulls the tail inside and hands it to a mitochondrion, and there it gets taken apart the way you dismantle a chain. Not all at once, but two carbon atoms at a time. Each pair goes into a loop of reactions, and at 2 points in that loop, a carbon atom is snipped off and stuck to oxygen, carbon dioxide. It dissolves straight into the fluid of the cell and from there into the blood. Your fat is now a gas, dissolved in your bloodstream, heading for your lungs. Here's where it becomes countable. Take 10 kilograms of fat and follow all of it. To oxidize 10 kilograms, your body has to pull in about 29 kilograms of oxygen. That isn't a slip. The oxygen weighs almost 3 times what the fat does, and you breathe in every gram of it. So the reaction starts with 39 kilograms of material, 10 of fat, 29 of oxygen, and nothing is allowed to vanish. 39 kilograms has to come out the other side. It comes out as two things: 28 kilograms of carbon dioxide, 11 kilograms of water. Add them, 39. The books balance exactly because they are not allowed not to. Now pull out just the atoms that were originally yours. Of your 10 kilograms of fat, about 8.4 leave as carbon dioxide. The other 1.6 leave as water. 84% of the fat you lose, you exhale, and 28 kilograms of carbon dioxide is not a small object. As a gas, it fills about 14,000 liters. That is a cube roughly 2.5 meters on every side, somewhere between a large wardrobe and a small bedroom, made of what used to be 10 kilograms of you, released a few grams at a time over months. And carbon dioxide has exactly one way out of a human body. It rides in the blood to your lungs, it crosses into an air sac, it leaves on the next breath out. That's it. Not through skin, not through the gut, not through sweat. One door, which leads somewhere strange. When a body is losing weight, the organ doing most of the removing is the lungs. Not the kidneys, not the sweat glands. The lungs are the main exit for body mass, and they do it about 20,000 times a day without being asked or noticed. For scale, on an ordinary day, a person breathes out something close to a kilogram of carbon dioxide. Most of that carbon came from the food they ate that day, not from anything stored. But it is the same door, open constantly, and it does not distinguish between a carbon atom that arrived this morning and one that was put away last winter. The water is less tidy. It leaves in urine, in sweat, in breath, in tears, anywhere water normally goes. But it's the small share, and it's the share people already assume. The bulk is gas, and gas is invisible. At this point, a thought arrives on its own, and it's wrong, so it's worth taking apart properly. If you exhale the fat, could you breathe faster and get rid of more? No. And the reason is exact. Breathing doesn't drive the reaction. The reaction drives the breathing. Your cells oxidize fat at whatever rate their work demands, and the carbon dioxide arriving at your lungs is a receipt for work already finished. Breathing harder doesn't create any. Deliberately hyperventilating clears carbon dioxide you had already made faster than you made it. Your blood chemistry shifts, you get lightheaded, and not one extra atom of fat has moved anywhere. The breath is the it was never the cause. Now follow the carbon one step further back, because it didn't start in you either. Every carbon atom in that fat molecule was in the air once. A plant pulled it out of the atmosphere as carbon dioxide and used sunlight to build it into something solid. You ate that, directly or one animal removed. Your body took it apart and put it back together as storage, and now it's gone back to the air it came from. The whole thing is a loop, and you are a section of it, not a container that things go into and disappear from, but a place where atoms pause on their way somewhere else. The reason almost nobody knows this, including most of the professionals who were asked, is that the exit is silent, invisible, and constant. Nothing about breathing feels like it's carrying material. It weighs nothing in your hand, it leaves no mark on anything, but it's the mechanism. It has always been the mechanism. So, back to those 20,000 breaths. Each one carries a small quantity of what was structural material in your body out into the room you are sitting in. Not as a metaphor, not as heat, not as energy, as gas built from specific carbon atoms that were inside a fat cell a few hours ago. The question was where it goes. It goes into the air. You put it there yourself, without effort, without attention, all day and all night, awake or asleep. It has been happening the entire time you have been watching this. And the strangest part isn't that the answer is surprising, it's that nothing was ever hidden. The only reason it feels like news is that almost nobody thought to follow the atoms all the way out, which makes burning fat a much stranger phrase than it sounds. Nothing is consumed, nothing becomes energy. A long chain of carbon and hydrogen is unhooked 2 atoms at a time, joined to oxygen you inhaled, and released into a room. One thing worth saying plainly: this is a description of a chemical pathway, not health. H advice: knowing the exit route doesn't change anything about any individual situation, and the person who can speak to yours is someone able to examine it. If that was worth knowing, the next one follows something else your body runs constantly and never explains. Subscribe and it will find you.